Welcome to all, or rather I would like to tell a very warm welcome to real structural engineering knowledge learning part. Moment of inertia. See, when you write or when you consider moment of inertia, don't get worried this way, you write correctly. Moment of inertia of an area or lamina or cross section of a structural member. Three different terms. See, lamina is a plain area. I told it has got uniform thickness throughout, but thickness we don't consider. This all I told in centroid, or it is an area, or actually in structural engineering it is cross section of a structural member. So about an axis. See, you continue. See, what you write is moment of inertia of an area or lamina or cross section of a structural member about an axis. Write that much. Below write, moment of inertia is also called as second moment. See, same thing. Second moment of an area or lamina or cross section of a structural member about an axis. Or rather, sometimes, see, there are two moment of inertia are there. There is another term called mass moment of inertia, which we don't consider in our class. In structural engineering right now, you don't require it. If requirement is there, I will consider later. So our concern or complete coverage is only for lamina or plain area, or one more is what? Or you can tell cross section. See, cross section means again area only. So instead of calling moment of inertia of an area, you can call area moment of inertia. If you write area moment of inertia, don't write once again of an area. See, already area is there. Area moment of inertia about an axis. So in future, when I go continue further, I can tell moment of inertia of an area, or I can tell for a lamina, or I can consider cross section of a structural member. Every class I will not tell. So I will stick to one thing now. I will consider area. That's all. Sufficient. People will be there to comment. Let them comment. Now, note, today's class, all basic concepts and class, I will tell something now, basic concepts and some mathematical part. And remember, today's class is for everybody, those who want to learn. Suppose he is not in civil engineering, maybe somebody from mechanical engineering. They don't require too much, see what all I explain further next class. That much knowledge, actually if they get the knowledge, well and good. But some people are there, even those who are in civil engineering, those who are studying structural engineering, they will tell, I do not want to understand beyond a limit. My capacity is lesser. Okay, then today's class is for everybody. So today's class, all basic concept and the mathematical part, some theorem, some explanation, and I will not tell what is actually moment of inertia. No, suppose you use a textbook, what they will tell? Consider elemental area, they will write area of the moment of the area, then they will write second moment of the area equal to, this is called moment of inertia. Then they will tell parallel axis theorem, perpendicular axis theorem, and then they will use the term polar moment of inertia, then radius of gyration, section modulus, then product of inertia, then they will start expression for moment of inertia, they will start. Like textbook. So therefore, this is general concept today. That's why today's class, you see the thumbnail there, I squeezed the other things like engineering, mechanics, systematic course, big letters. I used to write class number so and so, lecture so and so, part 3, that's all. Now I squeezed it and introduced one extra part there. Starting of the most powerful term or concept, something like that, in structural engineering, that is moment of inertia. That is today's class. Next class, remember, is exclusively, next class is exclusively for structural engineering, where you will understand what actually is moment of inertia. With plenty of examples and very thorough explanation, I will convince everybody, whether you are not in front of me, if you go through everything I tell in the class to next class, you will finally understand what is moment of inertia. Like I told, happiness. Explain. Not facial expression, no, should not show. Body, head is covered, happiness, but you know it. Pain, you know it. Sorrow or lazy feeling or feeling dull, yes, you can explain it, but you cannot see it. So I will see that. I used to tell you one thing, if you remember, see a beam, I can see moment of inertia. Some will tell, how you can see, sir? I can see it. Yes, I can see it. I will try my level best so that you also will see it. That is next class. So, but the next class, those who are not serious about all these concepts or deeper knowledge, that is all basic fundamental concepts or hidden concepts, or to understand what actually is moment of inertia, do one thing. After today's class, you jump to next class. I don't know class number. Today is lecture number part 3. I think lecture number 40 today. This is lecture number 40 today. See, today's class, part 3. Part 3 is for centroid and moment of inertia. Up to class lecture number 1 to lecture number 1 to 39 was centroid. Over. Now today lecture number 40. 40 onwards is moment of inertia, but centroid also will come, moment of inertia. Lecture number 40 today. This is today's class, and this is next class. Same thing, part 3, lecture number 41, I think. I don't remember. By chance, if lecture number is, if it is 41, make it 42. If it is 42, make it 43. By chance, if it is 39, make it 40. That I don't have to tell. People will find in the class he told lecture number 40, but actually typed, it is written there lecture number 39. Leave the class. You are not interested in serious studying. You are only interested in what commenting, unnecessary comments. Okay. So next class, 41, I will see that I will convince you, or somehow I got so many methods of explaining. See, example means structural example and also some other example. I will tell you. I will tell to next class. So those all required only for those who want to understand moment of inertia. See, with the regret I will tell, very sorry to tell, 99% of the people in structural engineering field, sorry, not students I will tell, students it will become 99.99. Those, I am not telling 100% because there are exceptions, rarely, very rarely. If you search, see, 99%, if among 100, maybe one, I doubt one also, 99% of the people, they know how to find moment of inertia, they know all mathematical part, maybe they are knowing, but they do not know what is actually moment of inertia. What is that term? First of all, significance, what is the real meaning of moment of inertia? Very sorry to tell, I know it. So I will see that those who are serious, if they go through all next class, if they go through the 99%, I will tell almost nearly 100% of the people who study from me. It is not that I am boosting myself. I know my capacity. Who study from me will understand what is moment of inertia. So keep in mind this one. Now, so remember now onwards, I will not use every time area or lamina or cross sectional. It is difficult. When I start question later, I will tell once for all. So now, as I go to next part, I will use the word area. Moment of inertia of an area. See, moment of next, I will write. So now when I come next time, second part now, today, I will tell now only. So that No confusion. So therefore, as I restart once again now, after a pausing of recording, when I come back, see, when I come back, when I am back, when I come back, instead of telling one day moment of inertia of an area, another day moment of inertia of a lamina or cross section of a structural member, etc., or second moment of the area. If I use second moment of area, don't use once again area there. I will tell moment of inertia, inertia of, sometimes I will tell of area, or occasionally of cross section. Cross section means, or simply section. Circular section, circular section means circular cross section. So I may use the word area or cross section. Remember, cross section is also area only. Lamina also is area. Okay. That way I will use it now. When I come next time, I will use all definitions, or for some theorems are there, I will use the word area. See, in the beginning when I consider some theorems and basic derivation, I will use the word area. But when I go later for derivation of expressions or for numerical solve, major times I will use section for the given cross section. Either I will tell given cross section or given section or rectangular section, anything I will use. Every class I won't use the word area, lamina, etc. Okay, this much will be clear. I will be back now with, I told you today's class is mathematical part and no hidden concept or the real meaning that will not be told today, because majority of people do not want it. If they want, next class is there, exclusively next class. Okay, I will start. Now we will start basic concepts. Consider an area as shown in figure below. See, it is a complete area or a lamina of area A. I will call area. Total area is A. See, this complete area is A. Anything, either capital A or small a. Right now capital A. Okay, then in this area, see, you consider elemental area dA. That is, within this area, consider, see, elemental area dA. Elemental area means very, 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 very small, infinitely small. These all concept will come next class. For you, this you already know in centroid. I should not explain more. Elemental area dA as shown. See, this dA is the elemental area. Now consider three axes for you. One axis AB here, randomly. One axis CD, one axis EF. Consider axis AB, say, let it be horizontal for understanding. Axis CD, let it be vertical. Axis EF, let it be inclined. See, for horizontal axis, distance is vertical. For vertical axis, distance is horizontal. For inclined axis, distance is perpendicular. You know it. Now, see, this is AB is horizontal axis. Let Y, see, Y, which is a variable. There are so many element areas are there. See, one more area here, one more area here. That all next class. That is concept class. Today, basic. Let Y be perpendicular distance from DA to axis AB. See, Y, vertical distance. See, horizontal axis considered vertical distance. Let X be, see, perpendicular distance from DA to CD axis. Let Z be perpendicular distance from this elemental area DA to EF axis. See, this some will comment. See, sir, X is this way, Y is this way, Z is this way. No. This Z is not that Z. This Z is not that Z. That Z comes when you go to three-dimensional. If suppose you want to consider two axes in the plane of the, I forgot one thing. Let axis AB, axis CD, axis EF all lie in the plane of the area. You can't take somewhere else. See, axis AB, axis CD, axis EF all will lie in the plane of the area. Later, when you go to polar, at that time I will tell you, or when you want some perpendicular distance perpendicular to plane of the cross section, then Z will come. So this Z is not your XYZ analytical geometry. Y is a vertical distance, X is horizontal, Z is inclined for us. I can take R. If I take R, what happens is later, R I am taking for radius of gyration, my symbol. Of course, if I take some other symbol, say D, then what happens is, it won't look like a variable. So Z looks like a variable. So this Z is not that three-dimensional Z. Inclined is I am calling Z, that's all. See, symbol is our choice. Now, consider AB. Now, one by one. First, consider AB. See, moment of the elemental area dA about AB equal to dA into y. This you know it. See, moment of a force is force into perpendicular distance. Same way, moment of the area is area into perpendicular distance. Remember, moment of the elemental area dA about AB is dA into y. See, about AB is dA into y. This is called first moment of the area. Remember, which we considered while discussing centroid. When you discuss centroid, see, integration of dA by A, you consider first moment. You stopped there. See, remember, I should not explain more because moment of the area about an axis we already considered in centroid. So, area dA into y is the first moment. Then, now, moment of the moment. First of all, I am not supporting it. I don't like this word. Moment of moment. Looks very odd, but what to do? Everybody uses it. So universally people are using moment of the moment means moment of the moment of the elemental area, or it is second moment of the elemental area about AB. Once you take moment, once again take moment. Y means next class. See, why? What is the reason? Next class. For those who want to only understand and do the problem, sufficient for them. See, textbooks all, they will write this much only. They won't write feeling, what is moment of inertia, they won't write. So, moment of the moment means, see, dA into y is the moment. dA into y is the moment. Once again, moment of that one. So, dA into y, already moment into y, dA into y square, or second moment of the area, elemental area dA about AB. See, dA into y is the first moment. Again into y, second time moment, area is dA into y square. Remember, the second moment of the elemental area dA about AB is called moment of inertia of elemental area dA about AB. This is why, see, now it comes. Now do one thing, next class. That is detailed systematic explanation of technical meaning. Why it is called moment of inertia. Today what we will do, see, in the books all what they will write, the second moment of the area is also called as moment of inertia, they will write. So same way, the second moment of the area, I already told earlier, is called moment of inertia. Why it is called moment of inertia comes in the systematic class tomorrow, next class. Is called moment of inertia of elemental area dA about AB, about the AB axis. That is, the note, moment of inertia, our symbol is I. Throughout our subject, moment of inertia symbol is I, inertia. So I with the suffix. Suffix is always axis. Suppose I write IXX means moment of inertia about XX. If I write IYY, moment of inertia about YY. If I write IAB, moment of inertia about AB. If I write ICD, moment of inertia about CD. That way, right? I is moment of inertia, suffix is always axis. So therefore, I about AB for, see very careful, what I am writing, this is for elemental area dA, that is IAB for, that is IAB, okay, that is IAB. IAB for elemental area dA equal to dA into y square. Okay, this is for elemental area. Now I want to rub the board and continue little more. 1 minute. So already over. I stopped by telling I about AB for elemental area dA is dA into y square, moment of inertia of the elemental area dA about AB. Therefore, now from here, you come here. Therefore, this is the expression for moment of inertia for elemental area dA. Now mathematics. Therefore, moment of inertia of the entire area or second moment of the entire area. Entire area, either you call moment of inertia of entire area or area moment of inertia for the entire area or second moment of the entire area about AB, IAB equal to summation of dA into y square, sigma. See, when dA into y square is for elemental area, so for the complete area it is sigma dA into y square. Technically, this is the correct answer. Technically, but mathematically it is integration of dA into y square, because remember I rounded this one because this is more important. Right here, when you want to explain technically, it is sigma dA into y square, means see this dA into this y square, one more dA into this y square, one more dA into this y square, infinite parts are there, sum up everything, or sigma means integration, summation. Either you technically write sigma dA y square, but for solving for derivations or any application, it is IAB equal to dA y square integration. See, if you remember y bar, integration of dA y by area, same way. Now, don't waste time. Similarly, once again, don't waste time. Consider CD. Moment of the area dA about CD equal to dA into x. Second moment equal to dA into x, dA into x square is second moment of the area, elemental area dA or moment of inertia of the elemental area dA about CD. Therefore, directly moment of inertia of entire area about CD equal to sigma of dA into not y square, x square, or integration of dAx square. Same way, I about, see, now there is no suffix here, see, when it is elemental I write IAB for elemental area. Now when I don't write anything here means what? If I simply put I means entire area. Similarly, moment of inertia of the entire area about EF equal to dA into z square, summation or integration. This is the basic concept. Okay, now I have to go to second class, where, see, this is for those who want to know the mathematical part or those who want to study within a limited scope. That's all. This is the required. Now we will go for second class is one meant for those who want to really understand what is moment of inertia. Of course, very important. Even those who are not serious too much about the basic concepts also, if you understand, you will be happy. Don't tell, I understood little more. But remember, so many, I told 99% of the people outside in structural engineering field, they don't know what is moment of inertia. They know how to get it. But if I ask them, show the moment of inertia. Sir, show. How to show? I can show it. Because inner mind. So for second class is, that is, I told lecture number 41 is exclusively meant for a thorough understanding of moment of inertia, its a practical application and significance and real meaning of moment of inertia. I know So many will be waiting for it. There are so many people who told me earlier, sir, moment of inertia. Yes, sir, you told. We know how to get it, sir, but we know how to write expression, but we still don't know what is that moment of inertia. Yes, I will tell you. Okay, now I will next see and go for second. You forget about the second class. Second class I will write in a bracket for those who want real concept. Those people who are not interested, that's all. Now go to next class. You go to lecture number. If today is lecture number 40, today is 40, 41 you skip it, go to 42, where I will start two important theorems that is required for everybody. Parallel axis theorem and perpendicular axis theorem, and then I will explain what is polar moment of inertia. Then also I will explain what is radius of gyration, and then further one section modulus will come in the bending theory. Sufficient radius of gyration, that all I will tell in the next class. Then I will continue. See, after next fall 42 class, my thumbnail you can see usual what that big see what extra I wrote for these two classes. I will remove it. Continue once again, class number so and so, lecture so and so, under the name centroid and moment of inertia. But in the title I will write something. Earlier all I used to write moment centroid, now it is moment of inertia. But these two classes, today's class and the next class, I am putting extra there to highlight it so that people can note, oh, something special is there. Once they understand that one, then they will continue. Okay, I won't wind up the class. I will give two examples for you today. Remember, this is required for everybody, actually required. But it is more required for those who are interested in the next class, that is the concept class. For those who are in the concept class, what example I am giving is very, very important. So I will finish today only. What I did so far, I will use that one. Okay, I will write first and then start. Right. Now, before I conclude the class, two concept-based examples. See, find moment, this is required for everybody. Find moment of inertia of a rectangular cross-section of a member. Means instead of lamina or area, I am taking cross-section. See, 200 by 300. 200 by 300. About AB and CD. They are given. See, AB is at 120, CD is at 250 from here, given in the question. Using basic concept, that is integration principle. Okay, little fast I will do. To find I about AB, see only AB axis. See, 200 by 300. This gap is 120. Consider elemental strip of thickness dy. Why dy? Because AB is horizontal. You are considering vertical distance now. Therefore, when you take y variable, thickness is dy. Later, when you go for CD, x variable, thickness is dx. Okay. Thickness dy at y from AB. See. Consider elemental strip of thickness dy at y from AB. Let DA be area of the elemental strip. The area is dA. So dA equal to 200 into dy. Mathematics, width into thickness. That is elemental area. Therefore, moment of inertia of the entire rectangle about AB, just now we concluded, is integration of dA into y square. Limit will be, see, your rectangle is here. From AB, you are measuring all distance from AB. As you come from here, rectangle starts at 120, see, 120. And rectangle ends at from here, y. See, this is the initial y, lower limit. This is the upper limit. 120 to 420. How 420? 300 plus 120 is 420. Anyway, if anybody got difficulty for limit, little later in YouTube, I'll start uploading series of classes for so many do's and do nots, mistakes people commit, sometimes blunder they commit, sign convention problem, difference between equilibrium and section forces. So many things are there. I will explain. So IAB equal to integration of dA into y square, y 120 to 420 equal to 120 to 420 of dA is 200 dy into y square, or 200 into y square becomes y cube by 3, 420 cube by 3 minus 120 cube by 3. Answer will come, I already calculated, 4824. I am not done by integration. I did something else. You never bother. 4824. Oh, one thing forgotten. Unit for moment of inertia, I forgot to tell. Okay, make a note somewhere. See, when you, before this example, write it. I forgot it. See, moment of inertia is always, whether elemental area or whatever you take, it is a second moment of the area. So it is area into distance square. Distance square. Area is linear square. Distance is linear. Distance square is linear square. Linear square into linear square is linear power 4. Therefore, moment of inertia dimensionally is linear power 4. If you consider all in millimeter, millimeter power 4. If you consider centimeter, centimeter power 4, write everything. If someone will ask, sir, if you consider some of them in millimeter, some of them in meter, I will tell, nonsense, don't talk. See, in Indian rupee, 20 rupees plus 30 paisa, you cannot tell 50 or dollars. $50 plus 40 cents, is it 90? It is $50.4, or convert, you require conversion. Everything should be in 1 unit. If you take linear millimeter, moment of inertia is millimeter power 4. Make a note. I forgot it. Okay. Now, you got 4824 10 to the power 6. Now, do one thing. Note. Class. Right now, today, you believe me. Because there is a theorem called parallel axis theorem. Axis theorem. I have not told you. It will come immediately now. So, little later, once I explain parallel axis theorem, I will take an example. There I will write maybe not 200, say 150 by 450, say 75, 180, like that I will write. I will solve that question. Full explanation I will give. Then I will tell, now go back to the first lecture of moment of inertia and understand that shortcut. So today you have to believe me. Later I will explain. So no explanation, directly I about AB, everything will come later. Today never bother. Equal to 250 into 300 cube by 12. Just you believe me. You have to only believe me now. IG plus area 200, okay, not 250. 200 into 300 is the area into 120 plus 300 by 2. Whole square. That's all. This is the correct 200 into 300 cube by 12 plus 200 into 120 plus 300 by 2 whole square. Calculate. I will calculate this way. 4824 10 to the power 6. 4824 10 to the power 6 millimeter power 4. Right? Oh, same answer. Today you just believe me. Sometime I will tell. For that matter, when people study from me, mechanics, engineering mechanics, strength of materials, structure analysis, RCC, steel, pretest concrete, any subject, you have to believe me. And I think by this time, you will agree that I can be believed. Okay, that is your choice. So therefore, we got I about AB, because today there are a lot of recording problems, some camera problem there. Sometime I forget, I am recording someone for second time, or one of the part for third time. I forgot to earlier see, I finished AB, then went for CD. Then AB recording did not come. I changed everything, but here CD was still maintained. That's why I recorded once again. Actually, I should have told in the comment. Okay. Any mistake? IAB. I think nothing. I think everything is okay now. Okay. Because I got fed up of these repeated recordings. Okay. Now I will go for I about CD and close the class. Okay. Now, concluding part of today's class, how to find I about CD. See here. Take a strip, elemental strip. Element area is dA. I told you already, elemental area is dA. You write here if you want, neatly. Area is dA. Consider the elemental strip. See, when y is the variable, thickness is dy. When x is the variable, thickness is dx. Elemental area strip of that, consider elemental strip of thickness dx at x from here, from CD. Why CD? Because we want moment of inertia about CD. Then let dA be area of elemental strip equal to O. It is 300 into dx. Oh, see, I forgot it. I did not change it. Okay. The area of the strip equal to, now it is 300 into dx, dA. So I about CD equal to integration of dA into x square, or 300 dx is the area into x square integration limit. See here, our rectangle this way starts here, ends here. So starting point of rectangle from CD is at 250. Ending point from CD is 250 plus 200, 450. I told you, for limit I will take one more class, not structural engineering, general class in YouTube, where series of classes I am uploading, do's and do nots, what mistake you make, what technical mistake you make, sign convention. Along with that one, I will tell one class exclusively for limit of integration. Okay. So 300 dx into x square, integrate, now I can do it. 300 into x square becomes x cube. Now you do it. 300 into x cube by 3 means 450 cube by 3 minus 250 cube by 3. You will get 7550 10 to the power 6 millimeter power 4. And same thing I told. Note. Later, right now you have to believe me. Do not argue or do not start wondering how it. No, I still not told you anything. But I will write now, later. So right now, believe me, I about CD equal to I about its own axis. 300 into, not now, today you believe me, 12 plus this is IG plus area 300 into 200 into 250 plus half of 200. 250, this all I will explain later. Today not possible, because why? I told, believe me, 250 plus 200 by 2 whole square, calculate 7550. I got confident. 10 to the power 6 millimeter power 4. Right. Oh, this also tally. This is a shortcut method which will come in not next class, other class. Wait for some time. Later I will tell you. Now go back to first class and what shortcut I applied. Now you understand. I will tell that at that time. Now go back to the first class, that is lecture number 40, moment of inertia, first class. Now what shortcut I told. Now see there, you will tell, sir, very, very easy. Yes, not now, later. Okay. Over now. Now I will conclude the class. Those who want a very good knowledge, or those who want to come in the 100% group instead of being that 1% group of people who know it. I told 99% no, don't know. 1%. If you want to join that group of 100% with full control on subject and knowledge, next class is very, very important. It may be a lengthy class. It may take up to 2 hours also, but very, very useful class. You will get there, you will understand what is moment of inertia. Okay, we will meet in the next class. Thank you very much.